What's up, everybody? Welcome back. Today we're looking at debugging our neural network training. We're working on this like from scratch neural network framework, and he's not doing what we want, and we want to understand why. So for context, we want to scan barcodes as part of this like meal tracker thing I've been working on. One of the things that I wanted to do is like track ingredients, track like how much of everything I have in my fridge, and an easy way to do that would be like scan stuff as I put it in. Then like I just enter each thing, how much it is, and then as I use it, like the computer will know kind of how much of that stuff has been used. I believe that barcode scanning with a phone camera is not like an uber trivial problem. Yes, you can say people have done it before, but I would say I'm not looking at what they did, right? We're not cheating. We're kind of trying to come up with our own answer from scratch. And you look at stuff and there's like weird things like on an aluminum can, the black bars are actually mirrors. In some cases, like you've got like white splotches on top of stuff. Sure, there's like something scannable here, but trying to identify like what is dark and what is light might be kind of difficult. In cases like this with motion blur, some of these like black lines become very like faded. In some cases you have like obstructions over the bars. And so we're like, let's train a neural network to kind of like get rid of all of that stuff and just give us like a nice clean like bar signal that we can scan, right? That's kind of like the current idea. So obviously we're building our own neural network framework from scratch, right? So we have one dependency, OpenCL, I guess two dependencies, OpenGL and OpenCL, so we can use the GPU to display stuff and run stuff. And we've got like our first attempt at something to train, right? So we've had success training like the world's simplest neural network that will say like given two numbers, which one's bigger? But we're trying to upgrade to like a convolutional neural network that will predict the orientation of some lines, right? This is kind of like the first step of barcode scanning, right? So if you like hit play here, we'll see the red line is where the orientation of this like low resolution image, right? So like as I scan through different pictures, the red line kind of points across the bars, right? The blue line is supposed to be what the neural network predicts. And if we like hit play on this thing, we can see that it's like starts to converge on basically like halfway between every single label, right? So we have kind of like, we're predicting the X and Y or like directions of this line. You could predict like a single angle, but in my mind, I think that the 2 dimensions X and Y is like an easier training target because it's like super continuous. But I could be wrong there, but it just seemed like the easy answer for now. And yeah, it seems like it's kind of converging on like halfway between all data. It's really easy to prove this actually. If we change our data, so our data right now is always on the pointing up because every set of stripies has like 2 correct answers, right? There's this way and then there's this way. So we kind of like just discard any of them that are pointing down essentially. But we can easily prove this by if we go into our like randomization parameters. Fix it so that we always pick the ones on the right half or something. So somewhere we have like m pi in here, presumably. Sample barcode parameters. So he is going from 0 to pi. If we just say like negative pi over 2 to pi over 2, so this will kind of limit everything to the right half, I think, if we do this right. JJ, thank you for the prime. Right, so now we can see the red line is kind of like jumping around pointing to the right, and the blue line is slowly converging to point to the right now instead of straight up, right? So we have like a fairly good idea that the neural network is basically saying, hey, you're giving me like a lot of like answers, and I don't fucking know how to deal with that. Right, so like the best thing I can do to not be wrong is to just like average out all of your answers, and then I'm kind of like the least wrong, right? Which kind of indicates that it's not learning anything about the underlying data, right? It kind of is saying like, okay, I know how to like adjust my weights to reduce incorrectness, but I'm too stupid to actually look at the pictures, right? And so today I want to try to fix that. My current suspicion is that how we are like the way that we're like getting how do I say this? So the way this is set up is we take like an image, right? Ah shit, ad break. Fuck. Sorry guys. I meant to snooze that. But you take like an image and you throw like a box over this image, and you kind of like run this box, slide it around. So you like put the box over every chunk of the image, every set of pixels, and what happens is this box represents kind of like multiplications that you do with the surrounding pixels, right? So if the box is here, you're going to like make this pixel by looking at the surrounding pixels in the input image and multiplying them by the numbers of the box and adding them all together, right? So this allows you to like extract features of this thing. It's called like a convolution, and it's kind of like the base of convolutional neural networks. We have these boxes are supposed to be learned by the neural network. So we kind of say, hey, like, can you make like 4 boxes, figure out what to put in them, and then like take the output of that image that you make by running, you're gonna like run those 4 boxes over the image, and you're gonna have now like 4 images that like might represent like a blurred version of the image or a sharpened version of the image or like an edge detection of the image, right? And then you do it again, right? So then you can say like, oh, maybe this guy was like predicting right, this guy was like doing like up and down gradient detection, this guy was like blurring it, and this guy was like sharpening it or whatever. And you can then like use this information to gain like higher level features as you run more boxes over and over and again, right? What we have is we have like a couple sets of boxes, right? So we might have like I think it's like 4 boxes, and then we run like another set of 4 boxes over that output. And then once we have like a little bit of information, we kind of just say, okay, look at every pixel in like these outputs and do like normal neural network shit where you kind of just like connect every output to every input. And you have like linear layers, I think they call them. Fully connected layers, I think is like another thing that I've seen. And then we have our output here. So I suspect that like when you get to here, you say, hey, I got the answer like 5, 5, right? And the answer was supposed to be like -1, 2. You kind of know how you got these answers, right? And so you say like, okay, like to make to kind of nudge this towards -1 and this towards 2, like how do I adjust everything in the past to like make these look more like that? And my understanding of this problem right now is that basically these guys are learning at the end, and these guys are basically doing fucking nothing, right? They're kind of saying like the information coming out of out of like the boxes that we're running over these things are basically garbage to the point where we can't infer anything about the image based off of that stuff. And so we can only just say, let me guess. And I'll guess halfway because that's the least wrong of all the time. That's my guess. I don't know. And so what I want to do is start by trying to visualize the gradients of these kernels back here is what they call them, these boxes, right? So what I suspect that we'll see is that as we get far back, as we look at like the gradients for the boxes, we'll see like very low impact. And I want to prove that first. Then I like know how to fix that if that's the problem. But first I want to prove it. Did you implement the backprop manually or using some sort of autograd? Manually. It's all by hand. So like there's lots of opportunities for bugs here, right? We could be doing backpropagation wrong. We could be doing like weight initialization wrong. We could be doing like maybe our activations are bad activations for this type of network, right? But I think what I want to do is just, yeah, let's just start by like trying to prove that we understand the problem. So what I want to do is in our little GUI here, we can right now show, like, we have the ability to kind of show every training sample. So we kind of like generate these images on the fly, and we run in some like training thread a bunch of math on these things, and we have the ability to like hook into that training thread and say, hey, could you like send me an image every once in a while and like your prediction for that image? And what we should be able to do is we should be able to like add like a little drop down here that says like, hey, could you show me what the gradients at this iteration, like how do you think that we should nudge these parameters so that they are more correct? And so let's start there. So the way this is set up is we have like a GUI thread that runs everything in OpenGL land, and then a compute thread that runs everything in OpenCL land. Those are just like two APIs for interacting with the GPU. One's kind of geared towards like compute and one's geared towards displaying stuff. And then we kind of, instead of like doing anything intelligent, everything that we want to like display, we just like copy from the GPU to the CPU and then back to the same GPU, which is kind of funny, but that's how we do it for now, and you can't stop us. So in here, I think the first thing we want to do is maybe add a drop down to the GUI that says what type of thing do we want, right? So I guess here we have like make a combo box. And I don't remember how combo boxes work in our in our GUI framework, but it looks like we have a preview widget, so like what we're going to display in the dropdown probably, as well as on click, what do we ask for? Okay, how does this thing work? So surely he must have, somewhere he must ask for like what he wants to show in the dropdown, no? Spawn overlay sounds a lot like it. And he has some thing that he renders on top of this thing. And how does he like render the stuff in it? So he's got like a frame, on click, make widget. Ah, here we go. Here we go. So when we click on the combo box, we pass in a thing that has a make widget function that I guess displays the rest of the stuff. Okay, cool. Cool. So I guess that means that we must define that thing, probably? Or there's like a chance that there's like kind of like a common one that is used for like typical combo boxes. Is there any like struct in here that looks like it's like typical combo box type shit? No. Okay, that's okay. And then when we call make widget, is it like tied to some lifetime? Yes. So we pass in like an allocator to this thing. Okay, cool. I think I understand. So here we could have a real GUI framework, the documentation, but we just wrote our own. So get fucked, I guess. The documentation is reading the code. Okay, so we have one widget that defines like the preview. So this is going to say, like, it's going to be like a label saying which thing we currently have selected. Which means that we need like a list of options for things we can select, which is kind of interesting, right? So what do we want to display here? We have like training sample, I guess, is one thing. And then we kind of have like each of the weights. Is that coffee? Yeah, it's instant coffee in a beer mug. What do you want from me? We have training sample. We have gradients, right? And I guess the question is gradients like a thing? How do I say this? Do we want like a combo box that says every set of gradients like is its own thing? So like the gradients for the first kernel, for the second kernel, for the third kernel. That seems like kind of hard to implement. Maybe if we have like gradients where we have like layer ID and like weight ID or something. Or maybe even we just say layer ID. So this guy gives us back, like, if we pick layer 0, which is a convolutional layer that has, like, he's gonna have, like, 4 3 by 3 by 4 boxes or something like that. Which is hard to display at once. So I think that maybe we say, like, layer ID, param ID, and then show one 3 by 3 by 4 thing from there. That seems reasonable. I think the combo box sounds complicated. It sounds like a complicated widget. What optimizer did you choose? Right now we are just using, I think it's called stochastic gradient descent. So basically, like, we just look at all of the weights or all of the gradients that we calculate, and we do like a slight nudge on all of them, and just kind of hope it lines up. Right, so we kind of say, okay, so this kernel affects this by this much, and this kernel affects it by this much, and this kernel affects it by this much. Let's just kind of like change them all, and then next round we'll see something else. I'm at activation. Right now we're using sigmoid, but I believe that that is a bad choice for specifically the problem that we're seeing. Right, I think that it causes the gradients to get really small because, or it can, right? Because if you say like, hey, I'm going to take off my outputs and I'm going to map them into a function that looks kind of like this. It's like if you are ever like over here or over here, your gradients are going to be like really, really, really small, right? And it'll be really hard to nudge them back towards the center. So I suspect that that is a problem for sure. Where like I've been reading that like if you do this activation, rel u, where it's kind of like everything below 0 is 0 and then everything above 0 is just what it was. The gradients here are like really consistent across the whole upper end. Sigmoid will do for now. I guess that's kind of what I was thinking, but maybe we'll see. Maybe we'll see. We'll see. Okay. So maybe for now, I feel like we've used combo boxes in ways that don't suck so much before. Hold on. Let me look at our image editor. Make combo box. What does this guy do? Oh, this is pretty gross. Select. Oh, he has a selectable list. Wait, that's actually maybe fine. I see. I see how this works. I see. That's actually not that bad. We can actually just not make the combo box. We can just say make selectable list, and then this thing's way nicer. Okay. Let's just start by having this guy. What does he want? He wants somebody who will tell him which thing is selected, probably. And like an action to run when one thing is clicked, probably. Can we look at how like this retriever thing is used? Retriever. So we have num items. And selected ID. Num items, selected ID. And get text. Okay, we can do that. Okay, wait, let's start there. We will make a little list. Add a list to the GUI. So we'll call this selected like view mode retriever. And here we have like different view modes, right? So we're gonna have like view mode, and we're gonna have like training sample is one thing we might want to look at, and gradients is another thing we're gonna want to look at. And depending on the mode, this guy is going to look at that thing. So he's gonna have like current mode is a view mode, and they're gonna say like, hey, how many items are in this thing? Which we would probably return a usize, probably. And I guess it's like the number of elements in this enum, right? Enum like meta field count, is that like a thing that we can do? Enum, can we do like type info of view mode like fields len? Here we go. So this is how many things are going to show up in this list. Then what was the other one? It was like selected index, I think was the other thing they wanted, if I remember correctly. And here it's like, we're going to look at self current mode, and we're going to want like stud meta field index of this thing or something. Hold on. No, we just do an int cast of this thing. Yes. Yeah. So if it's 0, it's training sample. If it's 1, it's 1. And then we have get text, I think was the other thing that they wanted. And I guess here we just return like a tag name of self current mode. Okay. So now we have somewhere like view mode is a view mode. And we start by at training sample. And then in our selectable list, we create a view mode retriever that like references this thing. Yeah. Something like this. And then he wants an action generator. So when he clicks, I assume it's gonna be like he wants to ask our application to like change the view mode. So he's probably gonna be like select view mode at this index, I would assume, and we're gonna be like he's gonna pass us just an index. So he's gonna be like, yo, here's an index, and you turn that into something that you know what to do with. So I think it's like this, and then we can just pass in that thing to the function, to this guy, the widget. So he's gonna be like, GUI action, gen select view mode. This is how I think that we're supposed to make this thing. And so what I'm hoping is that we should see, of course this doesn't fucking work. Let's see what's going on. Switch must handle all possibilities. So true. So if we get select view mode, we say view mode is int or enum from int of mode, I assume. Okay, then he wants selected ID, not IDX. Okay. Current mode, expected integer or vector found. Oh, this is enum or int from enum. My bad, not intcast. Okay, get text. Member function expected 0 arguments found 1. Oh, he wants get text at this index. I see. So this is like a tag name of IDX enum is a view mode enum from int of index. Then we say, give me the tag name of index enum. Because he wants to show them all in the list. Okay, he's like, yo. He's like, oh, this is I think that the type info stuff changed at some point. Yeah, this is wrong now, but we can fix that. Just a Zig update that we never handled because we didn't compile this anymore. Okay. Nice! Right, so now we can select between gradient and training sample. This thing is like filling the whole fucking box, which is annoying. So I guess we probably want to like limit its size in some way. Make box. So here we pass in that widget and then we set some like parameters to like clamp that motherfucker. So it's like, let's start this thing as like a, I don't know, 60 by like 3, maybe by 0 thing, height 0, and then we have like fill width or something. What happens if it's too small? Fill height, maybe? And then I think that this thing will only take up the height that it needs to. I think it's something like that. Yeah, here we go. So we set the width to like 300 or something. And then he like will grow vertically as much as he needs to. Okay, cool. So now we can like do this. And now when we click gradients, something needs to happen. Right? So, I think that, you know, we were saying that when we were trying to visualize gradients, we might look at, we want like sliders to adjust the layer ID that we're looking at and the parameter ID, right? So we're just gonna like select those things, then we'll figure out how to like clamp them later. Which means that the GUI, when we are in fill height mode, needs a way to like display or not display the extra sliders, right? Because when we're in, or we just show them all the time. Yeah, not sure. Also, can we do a little, give this thing a name, image ID here. Okay, so this is image ID here now, so we know what that is, and then we can start huckening like, we don't have to get too crazy here. Let's just do this. We'll say we have layer ID, and and param ID. Okay. We'll just leave them there all the time. Fuck it. I don't really care right now. We could get a little fancier later, but this is plenty good enough. Oh, oops. So here it's like update layer and update param. Boom, boom, boom. Update layer says, sir, could you update the layer? Cool. Update param says, hey, could you update the parameter? Cool. And then somewhere, our application is going to be like, oh, the GUI asked us to update the layer and the parameter. For now, we just will assign that thing unconditionally. But eventually we're going to have like clamps here on like the correct number of parameters and layers, and they're going to like depend on each other, right? So we'll figure that out. But for now, let's just start with, hey, I'm in gradient mode and I want layer 2 parameter 8 or something. Cool. So now the GUI has like buttons for these things. We just have to actually do something with those buttons. So it means that the GUI, when it like requests, fields from the, what do I call it? Dude, my fucking melting brain. When it requests things from like the training thread, he now needs to do that based off of like the current selection, right? So we're gonna like, you know, switch. I guess we'll go like this. We're gonna say like requests is one of these guys. GUI frame data request. Bad name. He's gonna say loss true, and he's gonna kind of by default say I don't want anything other than the loss. I always want the loss. Then we'll say like if, you know, view mode, switch on the current view mode, and if we're in like training sample, we say, hey, could you fucking give me one of those? And here it's like current image, right? But if we're trying to visualize gradients, right, we can say, hey, instead of looking at this training sample, could we get like a gradients for, and I guess this is not just the image index now, but this is like a struct of image index, layer index, and param index. Yeah. Yeah, okay. Nice. So now we're like, now I want the gradient of image index is current image, layer index is current layer, and param index is current param or something. Something like this. That seems reasonable. Okay. So now, can we like do like default is this, loss is true, or like loss only? Then we can do this. He doesn't like this. Why? It's here. Okay, cool. So now this guy can say loss only, and then the rest of this is the same. Cool. And then this says new request is equal to this. Okay. So now what I assume will happen is we'll see images here, but if I switch to gradients mode, this stops updating. which makes sense because he's not getting anything new. Maybe that's bad, but for now we'll kind of live with it. Okay. So now the other side needs to like respond to that thing, right? So we have our training thread. He needs to notice that that's what we're asking for and like pull that information off the GPU. So right now we kind of have this thing. We called it like notifier or something. I don't know if that's like a good name, but that's what we have it called right now. Actually, let me just make sure that we're committed in this state because I don't really know when the last time we committed was. Okay. So like we kind of have this training loop that on each frame, we can call it, when he like makes stuff, he says, hey, notifier, just so you know, like we have this stuff. And his responsibility is to say, well, the GUI asked for this other stuff and you have it now. So could you like queue up a read to get that shit back on a CPU? And so if we want the, how do I say this? The like gradients for these things, we need to like convert these layers into layer indexes. So how do we do that? Right now we're kind of just like, we create layers of stuff that we're going to be like running shit through, and we kind of treat them as like independent things, and we just like execute them in order, right? So we say like our layer 1 is a convolutional layer, and then we have another convolutional layer, and then a few fully connected layers, and we just like fucking run them back to back. We need a way to like pull out, I guess like we need an interface, like a runtime interface, probably, that we can say, hey, give me the tensor that represents the gradients for this layer. That's probably what we need. So we have like, okay, so how does this work? We're gonna say, give me your fucking weight matrix. And it can choose how it wants, each type of layer will choose how it wants to do that. The idea here is that we just need something that we can like represent in a picture. So we probably will return like a, up to 3D tensor, and the GUI will know how to display any 3D tensor, probably. Which means that we need like, what I want is like an like maybe like gradient retrievers, gradient query or something, which is like a list of gradient query, which can now be like stored this way because it's a runtime generic. And here then we can say like, we can do, layer like query. You know what I mean? Something like this. Something like this. And maybe this isn't like gradient query, maybe this is like layer query, because like we might use this to both get like the gradients from these things, but also like their actual parameters if we want to visualize those as well. Maybe that's a thing that we might want to do. Okay, that's looking pretty good. So this like convolutional layer, we just need, this thing needs like a query type. I don't really know where this is going, but here feels like it's okay. And this thing is going to have like a function on him that's like get gradients. And then he takes himself as the query object, and then the like ID, param ID as a usize. And he returns a math executor tensor. Yes, okay. Yeah. That seems like pretty good. So then, like, the fully connected layer is going to be like, hey, I have a query function that returns a query based off a pointer to self, probably constant, is probably fine. Something like this. And he returns some, like, we probably have like query vtable or something, right? So we have like some function that's like what do you do this? So he's like, I'm gonna hold some function pointers, right? So like one of my pointers is get gradients. And he's gonna pass in some like opaque pointer. And then he's also gonna take in the param ID. Yep, that's looking kind of right. And he's gonna return math executed tensor, because that's what he's supposed to pass in. Or that's what this guy's supposed to return. And this is a function pointer, right? So like kind of like this. Then like the actual, when we call this thing nicely, he's gonna be like, I have a vtable here. And I also have a context pointer. Type erased, and then he can just call like self get gradients with self context param ID like this and return it. Looking good. I think that this is also gonna have to take in an executor. No, he stores that shit. That's kind of surprising, honestly, but sure. Okay, cool. So now that means that like for us to return a thing, it's just like return, you know, vtable is query vtable, which doesn't exist yet, and context is ourself. And now we just need like query vtable is a query vtable, and we have to like implement those functions, right? So it's get gradients is equal to get gradients. That's gonna take in, you know, whatever the fuck, context, any opaque, param ID is usize, and he's gonna return a tensor. Okay, this is looking like something for sure. Did I spell this wrong? Gradients. Grad I before E, except after C, and a bunch of other times. Okay. And so he's gonna be like, yo, I guess parameter ID. I guess we kind of have to limit this in some way. Right? If somebody asks us for parameter ID like 9999, I think that this thing has to return an optional for if that parameter ID doesn't exist, right? I think that's like the most sane thing to do right now. What the fuck was that rule? I before E, except after C. And then what do they say? Or if it sounds like or if it sounds like an A, like neighbor and way. But then there's a bunch of other times where this rule is just wrong. So I've like kind of in my head kind of truncated it to I before E except after C, or a bunch of other shit, fuck English. You know? That's the rule. That's the rule. Just memorize words for fuck's sake. Yeah. Yeah. Fucking English, man. I like to just flip a coin and do it that way. Okay, so this guy is gonna be like, if param ID is... I guess here we just like discard parameter ID, to be honest. Here we're just always gonna return the entire weight matrix, I think. And then we can visualize the weight matrix as like a 2D grid in the GUI. Oh, I guess we have weights and biases. So I guess we do like this because we're storing those things separately. If param ID is equal to, I guess we switch on this thing. And if they ask for parameter ID 0, we return self weights. And if it's 1, we return self biases. Else we return null. And then here we need self, so we say self is a pointer to a fully connected, which we can get from a pointer cast, a line cast of context. Easy. Easy. Okay, so that's the fully connected layer kind of done. And so the convolutional layer is going to have something very similar, right? He's going to have a these functions now that he has, query vtable, get gradients, query, it's just get gradients now is going to look different. So he's now a, what is this? A convolutional layer. And if, I guess we, this thing is like 140 tensor. Which is not what we want to like display. Which makes me think that we want like a tensor slice or something, which doesn't really exist right now. Yeah, that's interesting. Oh, also, math executor tensor here is like all wrong. This depends on what the type of the executor is, so it's kind of like this. Okay. So what do we do here? I guess we could like return like the slice that we want to pull out of this thing. Yeah, because like we don't have like the ability to like say this thing lives in GPU memory. Here's like a like part of it. And maybe we just need that. I think this has come up a few times. So can we like, if this thing just gets an offsets field, does that kind of solve this? Because then our dimensions, like offset comes from here, size of the tensor is kind of defined by the dimensions, and then we just kind of like adjust our dimensions for this buffer. And then even here, maybe this thing just goes in here in tensor dims. So like in like the vast majority of cases, it's just what we were doing before. Right, so here we're like offs is 0, offs is 0. But then we can say like, we could have like slice here. And if this thing is still requiring that like the data that we're accessing is contiguous, we can like, maybe we say like index outer or something. So this says like, hey, take a thing that has like 4 dimensions and turn it into a 3-dimensional thing where you're like looking at one slice of that. That doesn't seem crazy. Okay. Which means that like here I think we have to, we can actually reference the same slice of indexes here actually, but it's mutable, which is bad. So I guess we will copy it. I think that's a little dangerous, but like whatever. Maybe those dimensions should be constant. Not 100% sure there. So here we like we calculate an offset, which is like for I guess we have like if inner is equal like length of this thing, the number of dimensions that we have, this is equal to 1. If it's 1 or 0, we can't do this. Invalid dims or something, right? Otherwise, we can say for each dimension in here, from the lowest dimension up to the highest, we do something with this thing. So we say like size is equal to this, and then we say size times equals value here. So like, you know, if we're at width here, we assign width, then we look at height, then we look at channels, and then we ignore number if we have like width by height by channels by number of elements. Seems kind of right. Okay. Or so then we say like offset is size times index. Okay. And then here it's like the dimensions are, we're like duplicating the existing dimensions, but from 0 to len minus 1, right? We're chopping off the last dimension of this thing. Okay, that's reasonable. And now we just have to like use this thing in some places. Maybe offset lives one layer up. Yeah, I think that this lives one layer up. Okay, so offset lives here, which means that this like index outer thing also lives there. So this guy is going to return a new tensor instead. Okay, and it's like we're looking at this is gonna be harder to implement, even like it's kind of like more correct for this to live here, but we're gonna have like a lot of I guess if we just define this to 0, then everything else kind of just works for now, which is fine. Okay, so then we have dims inner here. Everywhere we have like inner here, we're looking at dims here, here. And then this is, we update the dimensions of this thing according to our rules, but we still have our buffer. Okay. Cool. Does everything else still compile? Not quite, because we didn't finish this stuff. Okay, so now in our convolutional layers, we should be able to be like, here, we should be able to look at the parameter ID, and we should be able to be like, self kernel index outer param ID or something like this. You know what I mean? Math. What was we called it, right? Index outer, yeah. But he's gonna need an allocator as well, which is interesting. Because he's putting the new dimensions on this guy. Okay. But it looks like something like this is kind of right. You know? Something like that. I'm sure that we're going to hit all sorts of errors. And then also, like, whatever we do with this thing, we have to, like, handle. So, like, everywhere where we interact with a tensor now, we actually kind of have to, like, deal with his offset. Which seems kind of bad. I don't want to have to think about that if I don't have to everywhere. So maybe this, like, maybe what happens is this is a new type. I think that's better. I think that's better. Yeah, then we only have to think about this in like one spot. Right, so it's just like hit me with this. And then we have offset here as a U size or something, and then this is just return parent equals self, and then offset is offset. And then we don't need to allocate anything either, which is kind of nice. Yeah. And maybe we like store the size here as well. Size in number of elements. Num elements. I've seen vtable somewhere else. Is that like an elf format or something? This is like the like typical like manual like runtime interface thing where you have like a structure that defines like a bunch of function pointers. Like the standard library allocator is kind of like where I reference usually. So they have like pointer vtable. Vtable has a bunch of function pointers on it. And then you just kind of like create those functions and call them when you need to. It's like essentially like doing inheritance, but you're doing it manually because it's not like built into the language, which is fine. Which is fine. Maybe even, you know, nice in some ways. What is the type of this shit? This is like OpenCL layer gen with whatever like math tracing executor query. That's what this is supposed to be. Okay. So now why is he pissed? Oh, oops, these offset things are gone now. True. Unused local variable, sure. We'll get there in a second. Query doesn't exist? Oh, is this the wrong type? Yeah. That would do it. Found, expected this shit, found that shit. Put an ampersand on it. Expected this shit, found that shit. True, this thing has to be const pointer. True, 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 true. Self, this is again the wrong fucking thing. Nope, that's not the wrong thing. Wait, hold on. Query is fully connected. Wait, what's the problem? Cast starts const. Oh. It's fine. That's fine. Expected this shit, found that shit. Whoa. Expected type, const function, any opaque U size. Returns math tensor. Found, const function, any opaque CL alloc. Oh yeah, this is gone now. Yeah. Which means that this thing needs to return a tensor slice instead of this thing. Okay, which isn't really used much yet, but we'll figure this out. And then index outer is like an errorable thing now, I guess, which it shouldn't be, I don't think. Yeah, I think that this can't fail, right? Oh, it can if the dimensions are wrong. Fine, motherfucker. Fine. This thing now needs to like have a thing that takes any error, I guess. This thing has to be failable, which means this thing has to be failable. God damn it, dude. Why can't I try this thing? Expected type, this thing, found that thing. Okay, Jesus Christ. Expected type. What the fuck does this even say? Does he want any error here? No. Hello? What is he pissed about? We have tensor here, who returns tensor slice. What is he pissed about? I actually can't figure it out. Fuck! Why? Math zig. Tensor takes in index as usize, hype, any error. But like, do I need to do I need to like cast that somehow? Is there like something there? Payload types of error unions must match. Destination payload is math tensor. Operand payload is math tensor slice. Oh, okay, wait, that's a clue. I forgot to write slice here, that's why. The types just like straight up don't match. Does this work now? Yes. There we go, baby. Expected tensor. Yeah, here we go. There we go. Tensor slice here. And then here, I guess we need to construct a tensor slice out of like the tensor itself. So I guess for now, we're just gonna have like as slice. Right? And this is just like return offs is 0. Num elms is self dims num elms, and parent is ourself. And then here we can call like as slice, boom boom. Index outer here, it's mad again. God fucking damn it. Expected this shit show, found that shit show. Oh, math tensor slice cannot cast into error union payload. Question mark tensor slice. So I have to write try here. Yeah, there we go. We're getting somewhere. We're getting somewhere. Fucking language shit, man. How do you like Nyx? I'm a fan. I think that it's like one of those things that I wouldn't recommend to people, but I like it. Like, it's like if you found Nyx on your own, then it's like probably good for what you're looking for. But if you're like someone who doesn't even know it exists, then you probably don't want it. Okay, we finally have our fucking gradient query. So what are we doing with this thing? We are like letting we're probably like telling the GUI thread when we've calculated gradients. that this thing's like ready to fucking go, right? This is wrong, by the way. Yeah, this is wrong. This actually isn't get gradients. This is get weights. Because the layer doesn't hold the gradients, he holds the weights. The gradients are constructed externally. That's fine though. We can just kind of rename this everywhere. And so when we calculate the gradients finally somewhere, here, we have to do something with this. So it's like notify gradients. And we give him some stuff, right? So we're probably going to give him like the gradient query. And this isn't gradient query anymore. This is layer query. And we pass in the gradients as well, probably. I don't know where this is going, but it's going somewhere. So here he's like, here's my layer query. I don't know, man. Gross type, but whatever. And then the gradients here, which comes from like math, tracing, executor, gradients or something. Yeah, okay. So we have like something like this. And I guess we're gonna say like, hey, is there a thing that we're looking for? And does the thing that we're looking for, is he asking for gradients? Okay. Then we're going to do something with that thing. So we're going to look at like the gradients. I think that the gradients don't use the image ID, by the way. I think they, like, this doesn't need image index. He needs a layer index. So we're looking at if gradients layer index is like less than greater than or equal to query len, then we do something. Flag to GUI that this is no good. So we probably have like somewhere we're saying like we're going to like pull some data off of this thing. And this thing may have actual data or he might not. We probably want to store the dimensions here too. Probably. Hold on. Okay. Now what? Now what? Someone's gonna be like, when we get these gradients, we like, I guess we like assign those somewhere. So here we're like, yo, we have processed these things, but so they're like fucking empty. I think is the way to play this. Something like this. You know? Something like that. Otherwise we look at this thing, so we look at like query at gradients layer index. And we try to get the weights for gradients parameter index. Yes. Cool. Cool. That looks like something. Now we extract the gradients for this thing. Oh, oops, fuck. We're, gradient rec, I guess we will say. Cool. So now we're like, yo, could I get the gradients for, if this thing fails, we do the same thing. Const, can we do something like this? Like this, dims, grads, like this. Then here we can do, like, empty, like this. And then we can do this again here. Then if we have weights, then we can look at these things. So we're like extract the gradients based off these weights. But these gradients have like are according to some slice, right? So get weights is supposed to return a tensor slice here? No? Yes. Okay, we're getting somewhere. We're getting close. We're getting close. So then we have the gradients associated with this thing, but we need to use the offset from the slice. So when we read these things, we're like, yo, we are going to read this off of weight grads, offset of weight dot offset with weights num elms. Okay, so that's getting close, but we've like lost the dimensions somehow. But we can fix this by in our tensor slice. If we just say dims len here, that kind of fixes it, I think. Somewhat. Yep, something like that. Ooh, my nose is getting really stuffy. God damn. Sorry, that's gross. Because now we kind of have this thing, so this is like gonna give us back some results that will be triggered later. Where is our allocator here? I guess he comes from this, whatever the fuck this is. Okay. So here now we say if this succeeded, we have something in our gradients now. Dims is going to be I guess like the weights dims from 0 to like weights num dims or something. Probably something like this. Uh-huh. Then the data that we are sending back on CPU is coming from somewhere. It's grads and event. Okay. So the event is read res event. And data is read res data. Easy. Easy! Why doesn't he like this? Does get weights failable or something? Oh. Fee table, my bad. So this thing, we try it first, then we do the or else shit. Then he still doesn't feel like this exists for some reason. What's he mad about? Oh, U32 versus U size. Sure. Okay, so can we just change all this shit to U32? Okay. What's he mad about now? Data, no field data? What is it called? Grads. Fine. If you're gonna be like that. Dims line, my bad. Am I stupid? Oh. Here we go. We're like really violating APIs, but fuck it. Fuck it. Fuck it. I think there's like a chance that's right. So this guy, once we have this thing, we have to like finalize it and send it, actually send it to the thread. Oh, we also have to like stash this shit sometimes. Fix me work on pause. It's not broke. We'll just allow it to be broken. So what does this guy do? He calls builder.finish. This guy says, if we have gradients, what are we gonna do? We're gonna like wait for those things to the gradients to finish uploading to the CPU. If like I guess we have like a block here. So grads event or else break block. This thing was invalid. Then we can do like event dot wait chill. So this thing will now like be on CPU. And so we can say like result. I guess we need like gradients. And so this guy is gonna have dims. He's gonna have grads. And is that it? I think so. Yeah, probably. Okay. So we have dims is the thing we've been waiting for, or the dims that we have, and the gradients are the things that we just pulled off CPU or GPU. Nice. Nice. And then here we need this thing to equal null by default because usually we don't send it unless they ask. Okay, are we chill? Are we chill? Maybe. So now on like visualization side, we should start to see like a response that has grads. So let's just say std debug print got data of this size. Something like this. Got data of grads, dims, grads, len. Okay, so we should see when we switch to gradients, he's starting to send us data that's 3 by 3 by 1. And if we change the layer ID, we start to see 3 by 3 by 2. And if we crank this too high, he crashes, which is bad. Because we must not be handling that correctly. Okay, but we're getting close. So if we set param index just like too high, he goes into get weights. This thing can fail, and if this fails, we actually don't want to crash, which is probably part of this, right? But does this fail? When we call get weights here, yeah, here we should check on index outer. He doesn't bother checking that index is greater than or equal to self dims inner len. Return error invalid dims. Oopsies. We weren't checking that. No, if index is greater than the last element here. Yes. So if this is too big, then we can't do that thing. So now we should start to crash because we are getting invalid dimensions. So we're actually checking that thing correctly now. It's just that this thing now needs to like gracefully fail on that front. So I think it's like catch like this. I think it's just like this. Okay, so we put this too high. We're chilling. We put this too... Oh, we need to go to gradients now. So here I go too high. We stop receiving them. Okay. Loss of shape. Can we stop that fucking spam? Thank you. Yeah, so now I click gradients. He starts giving me some. The image stops updating. I put my layer ID like 0, 1, 2, 3, and then eventually if I go too high, it stops sending them to me. But the guys below that we do see. So like, for example, if I go to the first fully connected layer, we see one that's like 81,000, or sorry, 8,000 by 16. Then we see like 16 by 16, 16 by 2. This is hype. This is very cool. We're actually so close. Okay, so now what we have to do is we have to like visualize the gradients somehow. And so I think that a gradient visualizer is probably the play here. Like a widget that basically shows like, I guess this is kind of like a typical image, but I kind of want to show it as red is like positive and blue is negative or something like that. Yeah, let's try to do something like that. So in our like visualizer view, I think we just want like a new widget type. So here it's like gradient viz widget or something. This guy has to conform to the widget API so that we can like put him in our GUI somewhere. So I think we have an example of that somewhere. Here. Here we go. Here we go. Okay, so we need these functions. Render, get size. Do we need input state? Oh, but this is all gonna have like really common... We want like to be able to like zoom and like select pixels and look at their values and shit. So this guy actually has to follow... We have like a bunch of work already done there in our other widget. In our like training sample view widget. This guy already handles a bunch of like zooming and clicking and stuff like that. So I guess here we're just going to like overload this motherfucker. Which is fine. You could think about something that's capable of visualizing network weights as well. Yeah, I think that it's going to be the same. I think that what I really want is like just like positive negative buffer thing. So I think that like fix me, this needs to be simplified. But for now, let's just make it so that this image viewer that we're already using for training samples that has like the ability to like zoom and pan around and stuff. Can we make it so that this guy can visualize something else? I guess we're actually pretty close here. If we just we have gray tensor to RGBA CPU. This guy kind of like, we can just change this to be a grad tensor to RGBA CPU, something like that. And this thing is like a buffer of floating point, and a dims. Something like this. Okay. So we're like, give me RGBA thing. We should be doing this on GPU. But fuck it. This should be done by a GPU shader, but we're doing it by hand for now. Fuck it. Okay. Okay. So we allocate some RGBA data, which is based off of probably like this. I don't know if it's always 3 here, but like whatever. Okay. So we're going over data. And for each thing here, we're getting like if data I is less than 0, it's red, else it's blue, right? So here we're doing like abs value of this thing is going to be 255 from data at I, but we're going to absolute value this thing. And then clamp it, okay. Then it's like, here we're doing memset this shit to 0 up front. Then we only have to do red channel or blue channel here. And I guess we shouldn't at memset, honestly. We should do here maybe. Yeah, how do I want to do this? How do I want to do this? So 1 is always 0, 3 is always 255, and then here we set 2 to 0 and 0 to 0. I think that's play. There we go. That's something. That's something. Then here width is dim 0. Okay. That will probably work. Grad tensor to RGBA CPU. So if we get grads, then we do image is grad tensor to RGBA CPU. And this is coming from grads dims. And then we set the sample that we're looking at. So here, I think we just do no arrow, please. Okay. Looking reasonable to me. Looking reasonable to me so far. That, like, might work. All right, let's see. Okay, so we don't know. Can we set a multiplier on this thing? Because maybe, I don't know if this is like not working. I guess we can find out if it's not working by going to... Oh, okay, fuck. For... Hold on, hold on. Hold on, hold on. Sometimes this is 2D. Sometimes it's 3D. Okay, show me some gradients. Let's go up to a higher layer. Oh, okay, that's good. Okay. So this is showing me the weights of layer 4 and the biases of layer 4. So that looks like it's kind of working. But as I like kind of like walk my way back down, the gradients are like basically 0, which is basically what I was trying to prove earlier, right? So now I want to say, here, let's add a multiplier in here. And this multiplier is going to be applied here. Grad mol, I guess. So here we're gonna have like a little slider that we attach to this thing. And we want to see if these things are just like uber fucking small. Gradient multiplier. Gen update grad mol. Okay. So if we see that thing, we say, yo, grad mol, update that motherfucker. Okay. We could like do some clamping and stuff, but like whatever. Whoa. What's he pissed about? Oh, probably that I copy pasted U32 there. Yeah, this is supposed to be F32 here. Alright, let's try that. Okay. So now if I go to gradients, if I like start cranking this up, do we see anything? Okay. So layer 2, like we see jack shit all the time. You could just normalize min-max. Yeah, that's probably not a bad idea, right? And then like display that somewhere? Maybe? Maybe? Or at the very least, let's like print out the minimum and maximum. How about that? Let's just do, yeah, let's just... let's do this. Grad range. Is there like a thing for this? I guess var max. I don't know if there's one already. Max. Yeah, there's probably something like max here. Yeah, here we go. Grads. Okay, gradients. This is looking pretty damning, huh? Yeah, so as soon as we get to layer 2, gradient range 0 to 0. Everywhere. So of course this thing can't fucking learn jack shit, right? Because the gradients are 0. We actually didn't need all this visualization stuff to prove that, I guess, huh? But this will be kind of hyped to look at later, I think. This is kind of fun. I think. So it's layer 2, which is kind of surprising to me. Train thread or something. So layer 0, 1, 2. Right? So what we were calling layer 3 is index 2. And this guy, he has no gradients for his 64 by 64 by 2 thing. Which seems fucked. So it could be that, like, our reshaping and transposing here is broken? Right, because, like, his outputs definitely have, like, values associated with them, right? If we look at gradients, layer ID 0, 1, 2, 3, like, these values are small, but they, like, exist, right? So I guess, like, there's no, like, the reshape transform stuff, though. This all happens before the inputs of this thing. So okay, there's something here. Maybe it's that each of the 8,000 weights has, like, such a minimal effect on the output that it's, like, not working. What happens? Okay, hear me out. Oh, if the image. Okay, yeah. Wait. Hold on. If you have, um, okay, so the way that these, like, gradients are calculated is you have, like, a picture, right? And you, like, take the kernel and you, like, slide it over this thing, right? At each point in the image, the kernel is being, like, multiplied by something, right? So, like, here he's gonna, like, look at this guy's leg, and it's like, if I change the top left corner of this thing, it's going to affect the output value in the output here, where the guy's leg is, by, like, the amount, like, the pixels inside. If how do I say this? So, like, if the value of the pixel that it's multiplying by is 0, no matter what you do to the kernel weight, that will never change anything. And so if the image output by the convolutions we're actually at the layer where we, like, have, like, an image at the end, and we take every pixel and we put them into, like, a linear layer, right? So we have, like, 16 outputs here, and each pixel is connected to every single output here. And so we're kind of saying, like, hey, we're, like, multiply adding each pixel by some weight to get here. And we're like, how much does changing this weight change the output? But if the input pixel here is black, then this answer is always fucking 0. It's always 0, because no matter what you do here, nothing changes. So if somehow we've managed to make the entire image, like, basically black at the input here, then it's fucked up. I feel like it's something along those lines. Which makes me want to check that. It would be nice to visualize the outputs of each layer. But let's start. What if right now, instead of, like, running the first layers of the input, we just generated some data here. Just, like, to say, if there was data here, would we see gradients? That's kind of what I want to know. Layer 3 input hacked. So can we just do like random numbers here? I think this is 64 times 64 times num images. I think is what the shape of this thing's supposed to be. Layer 3 input hacked. Okay, what's he about here? I think this thing needs a random source. A place to get the random parameters from. Okay. Invalid matmul. Have I got the shape of this thing wrong? This supposed to be layer 2 outdim 0, 1, 2 by 3. So I think it's actually like this. Comma, not multiply. Still no? 8192 by 16 cannot matmul 4096 by 16? Oh. I guess there's times 2 in there. Is it the other way around? It might be. That might be why we did a transpose. Fucking APIs might be like fucking stupid here. Okay, here we go. So now we're back to him just like being like, I don't know what the fuck I'm doing. But it's kind of still doing the same shit. Where layer 2 inputs are still just 0. So how is that possible? Unless my indexing is wrong here. 0, 1, 2. Yeah, so layer 3 is the first fully connected layer. Let's just double check as well. That like this is how many things are supposed to be here. Okay, so we go gradients 0, 1, 2. Yeah, so here this is. That's interesting. So even if we randomly initialize the inputs here, he's still quite unhappy. What if we create tensor filled? We just say make this shit all once. Fuck random values. Fuck random values. Literally 1.0 everywhere. Right? Each of these things should have an effect on the output. They should have a lot of effect on the output. No? But we're still seeing 0 like gradient range here. Which is very surprising. Very surprising. Okay. So this guy's doing a matrix multiplication. What the fuck? It's weird to me that some layers of backprop are working and others are not. I think that we have to look at like the gradient calculation now, right? I think we have to. So when we're doing backprop, we are looking at like the matrix multiplication backpropagation, I think. Right? Because we are doing a matrix multiplication to do the linear layer stuff. And this guy's doing a matmul grad. And I guess here we're probably looking for situations where the two parameter, like we have parameters with index with lot size of 8192. Right? I think that's where this is happening. Can we just start here with like print, you know, this times this backprop. So can we look at like params oh, we need get CL tensor params a dims and self get CL tensor of params b dims. Okay, so this should at least let us know if we're backpropping here to this point, which I believe we should be. Right, so we do get to the point where we're backpropping to the 8192 by 16 thing to 8192 by 100. So here, these are the weights for this guy right here. These are the weights we're trying to look at. Now the question is why are they fucked? So the good news is we are getting in here. And so can we just say like, wait, so which parameter was it? It was the first one. So we're looking at the A output of matmul grad. So which is called matmul grad A kernel. So this thing is resulting in zeros. So the question I guess would be why? Can we say if A width is equal to A192, can we printf like backprop time? I just want to make sure that this is like where we are. Oh, fuck. Oh, no. Oh, no, man. Wait, are we live? We're live? Oh, thank God we're back. Are we like fully back? Oh, thank God. Woo, scary. I think we're alive. Okay, so obviously this was bad because we oomed ourselves with this printf, probably. This is probably supposed to be like and global id equals 0 or something. There we go. Okay. Woo. So if we do this, can we look at like what the fuck our inputs are? Can we print out like ACK? You know, like what are we fucking looking at here? Like, is this thing like stuck at 0 forever? Yes. Okay, so we are going through this thing and we're just getting zeros. So the question is like, why? Let's do this. Downstream gradients, downstream index. Okay. So the gradients that have made it back here are like essentially 0. So the so we're saying, hey, that makes it sound like the inputs to layer 3 or 4, like we have something that's like, you know, the sequence is like loss at the output, layer 5, layer 4, layer 3, right? And then like inputs here. And he's basically saying that layer 4 is not even fucking looking at this. Is kind of what it sounds like he's saying. Right? Because like we come down here and we say, this contributes to this contributes to this. And then by here we're saying, hey, like downstream, everything that like goes down is like nothing. So then the question is why is that happening? Right? You could have like, yeah. Why is that happening? I know that like weight initialization is like a likely candidate here for our problem. Yeah, so I guess then the problem is actually on the next layer up. So can we do this if A width is 16? Is that what we're looking at here? Our layers are... I guess if A width is 16... What are the dimensions here? And B height is 16. Which I don't know if we have a very... We don't really have access to that here. It was definitely training and learning when I tried it before. Can't be totally fucked, but that was with different in it. Yeah, I suspect that what's happening here is that, like, the weights for the layer are, like, just resulting in, like, if they're just all 0, that would explain this, right? So, okay, I need to think about this a little bit more. So we have, like, a fuck ton of inputs, like 8,000 to layer 3. He outputs 16. Then these guys to go to 16 more. And this is layer 4. So he's saying, basically, no matter what any of these values are, it does nothing to the output, which means that every single weight in layer 4 has to be 0. Right? Every single multiplication that's coming through here has to be like zeroing this shit out, right? I think. So if we print out the layer 4 weights, then we should see basically 0, which would be nice for us to have in our GUI, but for now let's like short circuit that. With your init, everything is positive. A sum of 8,000 inputs, all with positive weights, will saturate it for sure. Yeah, you're right, right? So we have... Yeah. And I guess if our activation function is sigmoid, then if we're all the way here or here, that would happen, right? Because at that point, like, no, our gradient is 0 in both directions. That sounds pretty right. That sounds pretty correct. So can we... How do we prove that? I guess we look at the output of layer 4 and see if it's like super, super close to 1 or 0. But layer 4 gradients matter, right? So... Wait, yeah. I'm confused. Because, like, these weights here that multiply with the layer 3 output, they have gradients. Right? So these guys are shuffling around. So they can't just be raw. They can't just be, like, fully 0. I don't think. Can we just, like, log them? Tracing executor to CPU. Keep CL alloc. And what is it? It's layer 4 weights. Any, I guess. Doesn't really matter right now. Yeah, so they're not like nothing. Why don't you use a debugger? I don't know what you're asking. I do use a debugger sometimes. It just depends on the problem. Here, these problems are like, I'm trying to look at like lots of data, so I think that the debugger is just gonna like, and the data's not even on CPU a lot of the time. So trying to use a debugger here, I don't really think helps. Yeah, so these guys are doing something. But then, like, if that is the case, how is it that it thinks that changing layer 3, that, like, downstream gradients from layer 3, i.e., how each of the outputs from layer 3 affects the output, are all 0? I think. Right? That's what it's saying here. If we go to back to our, like, fucking matmul gradient thing. Right, we were logging here. Downstream index. How many of these are there? Can we... A row times b width plus I. So I is going from 0 to b width here. How many downstream indexes are there? Can we just log this? I don't like fully understand what I'm looking at right now. Okay, so it's not a lot. Still can't believe too much printf can Yeah, a little scary. But it's because I think it's like buffering it somewhere. Why is my fucking Vim fucked? Okay, can we look at... Let's go back. Let's go back. So when we're doing our matmul grad, can I look at the dimensions of these things? I feel like that will help me, like, understand. So can we look at downstream gradients is of dimension like this. And I should probably do this after the execution, because otherwise it'll be at the top. And then here can we say if a dims get 0 is equal to 8192. I think that's what it is. Something like this. Downstream gradients. Yeah, so of the 16 outputs here, the 100 samples, so we have like 100 images. We have 100 images, and for each of those 100 images, we have how each of their 16 outputs of this guy affects the loss. And the claim here is that for each element in the batch, the output was 0. Yes. So how is that possible if the weights are not 0? Okay, so we have yeah, because it's like for one output neuron here, for each output neuron, we're connected to each of our 16 inputs, right? He is claiming that no matter what the value of the input is, changing it has no effect on the output. Okay, so this change is multiplied by the weight and this guy's output gradient. So I guess maybe it could just be vanishing gradients if this guy's gradient is like uber duper small. Right? Like, so when we're looking at the gradients, we're looking at layer 4 here. So this output is 2. So this is like the last, this is the index 4 is layer 5. So this is layer 4 here. And already here, these values, I mean, some of them are like, they're looking like they're in the range like 0.1-ish. Then we go back here. Yeah, I'm confused. My head. Do we know output is 0? I'd expect 1. Yeah, I guess we don't know what the values are here. So you're saying like maybe this guy's value is 1 because his sigmoid is like this. His output goes 1. We're like pushing ourselves all the way to the end. Oh yeah, I'm just like forgetting about like the sigmoid part in here, right? I'm just like not like drawing that in my brain. So it could be that a change. Yeah, right. So it's like we have like uh so it's like sigmoid followed by multiply by weight, and we know that here that changing the inputs to this thing has no effect. So it could be if we are all the way at the end of this curve somehow, that it's like this is essentially flat and the downstream gradients here are basically 0. Right? So it would be interesting to look at the sigmoid output, which means that when we do like gradient query, it would be nice to see the sigmoid output. I'm a noob. How do you classically deal with vanishing gradients? Is that where variable step size comes in? Uh, you have like initialization patterns, I think, that should completely avoid them or make them less likely, and then like yeah, different activation functions also. But I just want before like trying those solutions, I want to prove to myself that that's the problem, if that makes sense. Like I don't want to just change stuff and be like, oh, it works. I want to be like, oh, I had a problem and I fixed that problem. I think that that's like very different. Um, yeah, okay. I'm interested in the gradients of the sigmoid. Let's do that. So is that a thing that we can extract? I think so. Main train thread. So in here, we can look at sigmoid grads. Ooh, can we? Maybe not, because they're not like attached to a tensor somewhere. I guess they must be. So when we do like layer 3 execute, we need the gradients for this guy's tensor. Yeah. Which we don't really have. So can we instead can we like pull that out somehow? Oh, we need like this ID. So I guess we can just log it and then figure it out from there. Yeah, we can do like std debug print sigmoid with this tensor dimensions has like ID this. And hopefully this is like consistent and we can like just log this on another compilation. I think. I think. Uh Okay, 11 and 14. 11 and 14. So it's got to be the first one that happens. It's got to be. So we have this, we have two sigmoids, Layer 3 sigmoid is 1, so we want 11, probably. Probably. This is going to be sigmoid grad. And we're going to pull from... to CPU, tracing executor. Like, he has some sort of, like, structure inside where we can just shove that 11, right? Graph. So, like, this does something? What does this get us? There's get CL tensor? Do we have, like, get, like, non-CL tensor? I guess that's close. Sigmoid grad? Oh, no, wait, hold on. It's, gradients get 11. Here we go. Wait, this is looking good. Sigmoid grad is gradients get 11. Okay, wait, I think I got there. That was hard. There we go, I think. Then this is the wrong type. Gradients get returns a math executor tensor, so this needs to be math executor to CPU. There we go, we fucking got there. That was hard. Nice! Okay, so here we have proof that the gradients for the sigmoid output are all zeros. And so, can we look at the value of these outputs? So we can look at the layer 3 output. L3 out is going to be tracing executor to CPU of layer 3 out. And we should see these guys being like really fucking saturated, I think. L3 out. Aha! Ha ha ha! Okay! Okay, so I think we've fucking finally proven the vanishing gradients problem. Fucking finally. Right? So we know that layer 3 outputs are fully 1, which is just what is going to happen because our initialization parameters are shit. Right? What we did is we initialized with random values between 0 and 1, which is just wrong. Right? So if you look up weight initialization Wikipedia, they kind of talk about this a little bit, but basically, when you initialize your weights, this has an effect on like what happens down, like, of course, right? Your starting state obviously affects your ending state, but like it's important that you pick starting state that's like not shit. Your network isn't very deep, sure, but like if every single weight that we initialize is above 0, right? Which means that I think that we are just trending towards maximum. And so if we have like 8,000 things, oh no, wait, they're between 0 and 1. So we have a random, let me think for a second. We have random input 8192 right now, right? This is like random. So everything in here is in the range 0 to 1. This gets like everything multiply added to an output here. So all of these weights that are multiplied are 0 to 1 as well. 0 to 1 as well. So we're doing 0 to 1 times 0 to 1 into a sigmoid. Okay. So wait, what's the problem? Yeah, why are these always 1 then? Bias also 0 to 1. Oh, right, of course. So this is multiplied to this plus bias is here, right? So it's plus bias 0 to 1, and all of this goes through sigmoid, right? So in my mind, sigmoid, this thing should be like, this number has to be like really fucking big to get this guy to go to 1.0, right? So it could be that like all of our gradients are always positive. Maybe it doesn't start out this way, but maybe the layer 3 weights like just nudge themselves upwards initially, and that like very quickly turns this thing into saturating because none of them are negative to offset. Like it could be that because they're all pointing the same way, they're all positive, all the gradients are pointing in the same direction or something. Maybe? Because, yeah, I don't fully understand why this is a problem. Like, because in my mind, 0 to 1, 0 to 1, like, we should be, we should be out of, like, in the range of 0 to 1. If everything 0 to 1 is multiplying by 0 to 1. The only difference is that once we apply gradients, then we nudge everything in some direction, and maybe those get big. For one output, it's a weighted sum where all of the weights are positive and all of the inputs are positive. There could be 8,000 of them. Right from the init, it even could be saturating. Oh, because you're summing them. Right. So you're like, this thing is probably like, if these guys are evenly distributed, then like you're summing, you're maybe getting to like 800 off rip or something. Yeah, I see. So like before we do anything, like we could try doing this and then printing the output. So just like off rip, fully off initialization. Fully off initialization. We just like rip some random numbers, print the output, return. Yeah, it is just like straight off rip, which is interesting. Because, yeah, I mean, it makes sense because we're just summing all of these things. And so we're only seeing this now, we weren't seeing it before, probably because this is the first time we've had like such a large input layer. Okay, so if we should be able to fix this by basically just using a different initialization. So instead of just like random numbers between 0 and 1, which is like fucking stupid, I think like when I was Googling this, when I was like if I was like, we're stupid around here, right? We don't know what's going on. But if I like ask ChatGPT, like, how do I solve vanishing gradients in my hand-rolled CNN? I'm using like a couple conv layers, a couple linear layers, all with sigmoid activation. He tells us like use ReLU so that like you don't hit this problem, and also like use HE initialization, I think is what I saw before, right? He's like use ReLU, yep. And then he also like HE initialization, which I'm, obviously ChatGPT's a fucking idiot, right? We say this all the time. But I think that he is a pretty good, like, give me an average of the internet, right? So I've seen this word HE initialization many times, also like Googling the answer for this as so yeah, where'd he go? Yeah, HE, or use Xavier if you're using sigmoid. Am I guys, this is crazy, right? He's like, if you're using ReLU, use this function. If you're using sigmoid, use this function. And they're just like the same fucking function. But I think that this is just saying like, oh, these are slightly different. 1 over 1 or 2. Right? So we could try this. We have a normal distribution random generator already. 1 versus 2. Come on. Sorry. I couldn't see. I can't read. We knew this already. So we should be able to do this. And I think that I also read that biases, we are initializing all of our biases to the range of 0 to 1 as well. I think that we're supposed to initialize these to 0 by default. So create tensor filled, and I think we just should set these to 0 by default. I think. What is it? It's like Rand Gaussian, I think is what we called it. But I think our tracing executor doesn't have it. But math executor does have Rand Gaussian. Now, this guy doesn't take in a standard deviation, but we can make him. So here he's like, float is standard deviation. And then we go into our Rand CL. We have Rand Gaussian. Gaussian here. So here we just take in standard deviation and we multiply this here. Something like this. And then we're kind of chilling. So now here we should be able to be like, tracing executor, he has function rand. We want Rand Gaussian here. Like this. Okay. And now we should be able to, when we call this thing, use standard deviation, squirt 1 over inputs. Float from int inputs. I think it's something like this, if I understand this correctly. I might not, though. Something like this. Okay, let's just see if that changes anything. We can double check that it's right later. What's this about? Oh, wrong way. If you Google Camming he, it's obviously a guy. Yeah, it sure seems that way. Okay, so good news. We're not just like insta 1.0ing at the end anymore. If we do that this way, and if we then re-enable our training loop, re-enable the train loop, we're still using like fucked up inputs here. But at least like we should see gradients now for the, like I'm hoping. Right, we're seeing numbers. Numbers is good. We need to like disable these prints because it kills my bitrate. But now, hopefully, that's also... where was that in? That was in like matmul CL. We had a printf in here. Fuck that shit now. Those are fairly consistent, so that won't nail that. My bitrate will be fine. So now if we look at gradients now for layer 2, now we're actually seeing gradients now. They're very small, but if I start cranking this up now, hopefully I see something. I would have thought so. Oh, I think they're just really... Yeah, here we go. I don't know why... I'm a little concerned here that only some of them are present. Like, I don't know if this is supposed to be like an 8192 tall thing, right? We're supposed to be seeing 131,000 of these things, and we're only seeing like some of them in the picture. Wait, what is this? This is, oh, this is layer 4, my bad. Yeah, so that's maybe not good. But maybe if we start giving it like the proper thing. Those numbers don't look very random. Yeah, that's a good point. I do kind of want to look at, let's make sure that like the gradients, that like our initialization here is correct. Can we print out the numbers? Um, of the layer 3 initialization, I guess. So we want like layer 3 weights, I guess. So we want L3 weights is tracing executor to CPU using some stuff of layer 3 weights. Because you were right that the outputs looked a little bit, but I think these numbers look fairly random. Can we graph them? So if we're just like next shell LibreOffice. The numbers, what do they mean? Yeah, I don't know. LibreOffice. Okay, give me a spreadsheet. Okay, let me paste here. Okay, can I paste special? Edit. Paste special. Use text import. Okay, cool. Then can I graph this? How do I fucking put a chart into this fucking thing? Insert. Chart. This is not helpful. This is not helpful at all. I guess I want like a histogram, right? Well, I guess like, wait. What is this? Why is they're all really small, but then the first thing is 5.2 E01? That doesn't sound right. I must have fucked up the paste or something. All right, well, hold on. Edit, paste special. $523? Am I fucking high? Where is that coming from? Oh, you know what? It's probably that this thing is like too big for a paste buffer. I bet you it's like we're truncating this thing somehow, and that's like fucking up. So can we do something else? Can we go main here, and instead of printing here, I guess we can actually do this. Oopsies. 2 temp text. And then here we just go to the end of this line and delete everything else. We wait for Vim to just like freak the fuck out. I would like to save, please. Thank you. I would like to quit, please. Thank you. Then can we import that as a file? How do I do import? Open? I kind of want to like, I guess it's open. Yeah, here we go. Fuck. off. Can I like import transposed? I hate everything, dude. Templates. Wizards. Oh my god. Oh my god. Okay, we can like, I guess, do something like percent cat temp text sed s with the, you know, take a comma and replace it with a new line on like temp text. Is it something like this? Unknown command. Oh my god. Oh, you can import normal cut paste select cut paste transposed. Yeah, but it's like not it's not importing the whole thing because there are too many columns. Expression number 1, character 4. 0, 1, 2, 3, 4. What the fuck is it complaining about? Can I not sed new line? God damn it. What in the fuck? S? Yeah, why is he like unknown command? Sed match replace. Yeah, I understand that. Oh, S. You're right. My bad. I forgot the S at the front. Fine. There we go. Fine. Fine. You're right. I'm an idiot. I'm a fucking idiot. Okay, I get it. Oopsies. Open. Open. Okay. Graph. What am I trying to look at here? I don't want like scatter. This is not helpful. This is not helpful. What am I trying to graph? I guess I want like the histogram. I guess here this is showing that they're relatively random. But the dots, like we can't really see like the distribution from this. So I guess we need histogram. For what? 0, 4 L3 weights. We put in a bucket. So we are hoping that this thing has standard deviation of 1 over square root 1 over. Can't LibreOffice do a histogram on its own? That would be nice. Last time I looked this up, it was hard. Let's see. Yes, you can. Almost automatically. Wait a second. This isn't what I want. Plotting histograms in calc. Basically you need to start with a column listing of your data, a second column with the bins, and a third column for frequencies. Highlight cells in your frequency column. Yeah, this sounds like a lot of work. Wait. Array formula frequency creates a histogram data from unsorted raw values. Frequency. LibreOffice calc. What's this shit do? Just do pie plot. Yeah, I guess that's not crazy, huh? Wait, but I just want to see what this does. Ow. Data is a reference specifying a list of ranges of cells containing the data frequency distribution is required. This hurts my brain. I'm just gonna fucking make my. Do I just make my own? Do I just load the CSV in Python and type plot? I'll just do it this way. We have 1024 buckets. Memset buckets 0. What's he fucking pissed about here? Ampersand buckets? Okay. And then for each of these things, we like calculate which bucket. So it's like, we're expecting standard deviation of 1 over square root 1 over 8192, I think. Was that what we said? 1, yeah, square root 1 over 8192. So times 3 is, or times 6, I guess it's the width of this thing. Ish. Then we want this to be distributed over 1024 buckets. So it's like 1024 times weight over this. But then this will be in the range like negative 512 to 512, so plus 512 or something. I think it's something like this. 1024 times weight over stud math squirt 1 over 8192. I think it's something like this. Where's the times 6 going? Is this supposed to be bracketed? I think so. I think it's something like this. I think. If bucket ID is less than 0, or bucket ID is greater than 1024, continue. Then we can do buckets int from float, bucket ID is weight or plus equals 1, something like this. Something like this. And then we go like 4 buckets. Stud debug print the number of things in the bucket. And we'll see if this does what I wanted it to. What the fuck? What the fuck? Print. Oh, I see. I accidentally printed this as well. I see. I see. Okay, there we go. There we go. One more time. One more time. Open. Temp text. Okay. Then can we just kind of like graph this shit? Okay, good news. That's a normal distribution. That's a good news. That's some good news. So I think that like our weights are correct. That looks like a kind of random Gaussian distribution. And assuming that our math is right, this looks like kind of like the 3 standard deviation rule, right? If we count how many lines there are, this is not that many, actually. Hold on. Oh, wait, that's normal. Stud debug print this many. I want to know like how many we skipped. Included is 0, included plus equals 1, and then can we print included? Included this many. So hopefully we hit most of them, right? Most of the things should be in this. So 130,000 out of 8192 times 16, I think. Yeah, so 130,000 out of 131,000. So that's like approximately the 97% rule. So I think that is the correct. I think this is saying that we do have like relatively random weights, right? Which we saw from the graph before that was like a box, and they seem to be like Gaussian distributed in the range that we expect them to be. So I think we're kind of chilling all the way around. So I think that these weights are correct. Good. So then the question becomes, I guess I'm a little bit concerned still that the gradients at layer 2 are like not visible. Right? Like what we're seeing here is like only like some of these weights are okay. Oh, wait, actually. Hold on. What are we looking at here? Can we grad range is this, and then can we also print out the grad dims? Like what the fuck am I looking at? Maybe if you pause at the beginning, it might have better gradients. Yeah, good point. Oh, this thing is 8192 by 16. So we might be seeing a very similar gradients per row or something. Right? So like this thing is supposed to be 16 tall. So the problem here is that we're seeing that like for a given row in this image, every single or a given row in this gradient, every single weight is like approximately the same. They might not be actually the same, but they're very close. So it'd be interesting to print these gradients. Just a couple times. I just want to see if they're like actually the fucking same. Yeah, they are, right? So that's interesting. But these gradients are coming from some like whack shit. Right, which might be changing the equation a little bit, right? The gradients are all like we're feeding random input into this thing. So that could be affecting the answer. I'd be interested into going back to the a correct network. Train thread. Can we go back to like actually fucking executing what we want to execute? So instead of layer 3 input hacked, we're going back to an actual output. And we need to make sure that our convolutional layers are following the same rules, right? So, I don't know how these rules apply to convolutional layers, right? What is like, because here they were saying to make a standard deviation of 1 over square root of your like number of inputs. But here is our number of inputs related to image size, because our kernel is relatively small. I guess it has to be for the kernel. Ice Leo, thank you for the gifties. 5 gifties, much appreciated. Much appreciated. So, I guess we've kind of done this, huh? We're kind of on this now. Sometime before 2:30. Oh my god. We've been going for so long. Wait, fuck. Fuck. That's bad. I thought we were like an hour in. I've been having too much fun. Okay. So can we look? I guess it has. Let's just try doing whatever the fuck we did over here. And if it's fucking stupid, it's fucking stupid. But kernel is going to be this shape over number of inputs here. We're just going to call this width times height times in channel, and we'll just kind of see what happens. Maybe that's fucking crazy, but also, whatever. You can't fucking stop me. Okay, so what are we trying to do here? I guess like visualize gradients. Okay, so this is good. The kernels are, in fact, getting something. Yeah, we are now getting gradients all the way to the back, which is a really good sign. Yeah, so here we're seeing like a 2-channel. The fact that the kernel gradients are all kind of like synced in direction with each other is a little concerning. But oh, the fucking UI doesn't update on pause, which is annoying. But let's see if it looks like it's learning anything. Oops, we're nanning. So it does look like this guy is doing that shit where he's just kind of trending towards the center again. Right? He is just bisecting all of our samples, but at least we have some gradients. Yeah, good linking this isn't a bad idea. Okay, wait, what's going on here? So they are in their convolutional layer. How's the guy looking? Yeah, he's still just bisecting. In their convolutional layer, they are doing camming uniform, which I guess is like kind of the similar idea, I think. But they're just using squirt 5. So setting is the same as initializing with 1 over square root k here. What the fuck? What in the actual fuck are they talking about? So they just have, and I assume A is like the range. What the fuck are they talking about? That looks like math. Yeah. Then if bias is not none, they calculate some weights for the bias. Are we supposed to be biasing our convolutional layers? Surely, right? I guess we're just not doing that, which seems kind of bad. Yeah, I assume there's supposed to be a bias that we're not doing, which might be kind of like affecting the results here. Right? Okay, well, on the bright side, we have solved one problem. And it is that there were no gradients making back. We are still not getting a good answer. But we've been streaming for 2 hours and 40 minutes. This was not supposed to go this long. So I think this is a win. I think our network is bad. I need to do some reading about like that a little bit, but I'm just happy that we're seeing some colors at the beginning, right? So that's good. It means that they're propagating. Oh, I wanted to check also if the gradients on layer 2, now that we're using uh proper image inputs, are like still like consistent along lines, which it looks like they're not, by the way. It looks like we are seeing like variation in these now, which is good. I mean, there is still like a lot of like horizontal striping here, but I did see some examples of like, here, you can see like some examples here of like, at least the weights aren't like all exactly the same. With your current fix in it, no conv and just fully connected should solve this task at least. Oh yeah. So you're saying like, what did you do when you were saying you tried this earlier? Like, do you think that like just the three fully connected layers as they are is good enough? Or like, do you mean like add more? Like if I do like 64 by 64 by 1 here, and then kind of fuck layer 1 and 2 for a second, and then here we execute layer 3 on, we take our like traced batch, and I think we need to make them like, we need to reshape this a little bit. So we need to be like traced batch. We want this to have the shape now of 64 times 64 by num images. Something like this. I think it's something along these lines. Error 4096 cannot mount. Oh, it's the other way. We need to transpose as well. I forgot. Because they're fucking are fucking like linear layers. They have like weird expected data input, which is annoying. But we can live for now. Yeah, something like this. Something like this. Not so lucky still, huh? But I'm sure there's a way to fix this. I just, yeah, I'm sure that there's a way to fix this. I just don't know what it is yet. Okay, well, I'm sure there's an answer. I'm gonna call it here. More neurons also can crank up learning rate by a tiny bit. Fine, I'll give it a shot. You've convinced me. More neurons. 64. Fine. You've convinced me. We'll go a little farther. Oh, he is wiggling. And probably we can crank up number of images here too, actually. Like, times 10 that shit. I'm not really convinced it's learning still. Not convinced. But I think that we're closer at least. That's all that I really wanted for today, was getting to the point where these gradients actually mean something is like a big win for us. So let's call it there. We've gone too long. Thanks for watching, guys. If you like what you saw, we stream most days. We aim for 12:30 Pacific time to 3 or 4 Pacific time. It is 3:15 now. It might not because of the neuron number, but the thing. Yeah, I don't know. I'll look at it. We'll take another look tomorrow. yeah, some stuff goes on the YouTube. So if you're watching live, YouTube link in the Twitch description. Some stuff does not. It kind of depends on if I think it's like a story that can be titled in the thumbnail or not, essentially. If it's something that like the YouTube algorithm will promote or not. So if it's something that I don't think is YouTube algorithm friendly, but still interesting, the rest of the streams go on Twitch VODs or Patreon or as like YouTube member stuff. We do that so that, we can give something to people who want to support the stream. The stream will end when I run out of money. So, this gives you like some feeling that you are helping contribute to the longevity of the stream, and you get like a little bit of stuff in return. Yeah, otherwise, I think that's all we got to say for now. YouTube, peace out, and Twitch, let's find someone to raid.